Thank you, Kara. Thanks for that great introduction. Welcome, everybody. This is part 2 in a series of talks we're going to have on the Scaled Agile Framework. The video, for those of you who didn't see that previous webcast, the video is available on our website, so feel free to take a look at it. In that webcast, we had the author of the Scaled Agile Framework, methodologist Dean Leffingswell. So we had him present the Scaled Agile Framework. We spoke about a direction we were taking that to support complex embedded systems, the kind of systems we build in the aerospace, automotive, defense type world. The Scaled Agile Framework is built out of years of practice and experience on scaling agile practices in the IT domain. So they address some of the IT things. We're going to add some complex engineering things. Today's webcast is to more formalize those things that we're adding. And I think the feedback we got on the last webinar was that we want to see more of the formalization, as well as we had several questions about how do you apply it using the rational products. So in this webcast today, we're going to talk about that formalization practice, and we'll have a subsequent one, probably in a month or so, that shows you how you do that in the rational tools. That may expand to a couple webinars, frankly, because there's a lot of discussion to have there. Over the past, since the last webinar 6-8 weeks ago, we've taken this to several customer sites. We've had a lot of interest and engagement. We've been brought in. We've gotten a lot of feedback. So I think today's webcast will be a good one for everyone. Again, this is all based on feedback we've been getting from other organizations. So when I have a continuous engineering introduction, I think, to speak frankly, we still struggle a little bit with what to call this. It's SAFe 4, complex systems, complex embedded systems, engineered system, continuous engineering. I think we're falling out with the continuous engineering term, because we want to talk about the engineering practice requirements, design, traceability, those types of work that needs to go into the systems that we build, and then how to collaborate on those things. We'll have a quick SAFe review. A lot of those slides, I grabbed 4 or 5 slides from the previous webinar for those people that background or reminder that saw that webcast. We want to talk about, from an engineering perspective, how do we manage things? How do we do requirements, analysis, design, schedule, features, traceability, and work that into a more agile, more continuous, more lean environment. Just as some background, if we look at Agile, what does Agile really excel at? The challenge that Agile addressed when it was first started to gain a lot of emphasis 10, 15 years ago or so was really about the misalignment between development, test, and the business. And Agile came up with some really very simple practices to follow in terms of continuous engineering, backlog of work, sprint planning, and it's a very powerful solution to go get these people aligned so there's a common vision and a common understanding about the direction we're taking. Agile's pitfall or limitation, though, is that it only does it at the team level. So with Agile, we only really get alignment across a single team. There's been the community, the Agile community has talked about scaling this with scrums and whatnot, but SAFe is really the first method. The Scaled Agile Framework is really the first method that is a holistic method of scaling these team of teams that, like Scrum, talks about intentional meetings, artifacts, and things to produce to align those teams. So really that's one of that is our major goal, is to get alignment and collaboration across these team of teams. And I think that is becoming more critical in our complex engineering system space, our continuous engineering space. We see a lot more, if we rewind, this is a story I tell frequently, that if we rewind 10 years ago, a lot of our systems, maybe more than that in some domains, our systems really built from the parts, right? We had one domain or team building out part A and part B and part C, and as a system engineer, my job was to just grab certain versions of each part, decide how they're going to be connected together, and there was my system, create a bill of materials, and off we go.